Can you see my screen?
Yes, we got you. Good.
Okay. So, good afternoon, everybody. Our project Repairt focuses on creating the hardware and software cyber infrastructure that will make XApps secure by design in the context of Open Radio Access Cellular Networks, which are also known as Open RAN or ORAN. So let's start from the beginning. Let's talk a little bit about ORAN first. What is ORAN and why is ORAN fundamentally important from both a technological and strategical standpoint for the United States? Well, so in a nutshell, ORAN aims at radically redesigning the cellular architecture by enabling flexibility, by virtualizing network resources, establishing interoperable interfaces among different parts of the RAN, and fine-grained data-driven control loops. So it's basically the alternative to closed-source monolithic RANs that are being commercialized by other vendors, most importantly, Huawei, right? So Open RAN is of fundamental strategic importance for the US and its allies. So, for example, the Future G office at the Pentagon is investing a lot in Open RAN, and we have the NTIA Innovation Fund, so to further develop Open RAN. So overall, a lot of momentum is being created in the US to push ORAN to the market. From a research standpoint, ORAN is perfect since almost everything is programmable. So basically, as researchers, we can develop our own strategy, control algorithms for cellular networks, and we can test them in real-world commercial-grade equipment. This is something extraordinary if you think that up until 5 years ago, we had to struggle like months and months to make a cellular network work with software-defined radios, okay? From a software perspective, ORAN becomes very interesting because it brings a new concept called extensible applications, or XApps, where the key idea is that these XApps will provide network control, mainly based on AI, to effectively implement dynamic RAN operations that I talked about before. So, as I said, XApps are based on software, so they will be developed by third parties and placed in shared XApps marketplace. So this is the beauty of Open RAN. Because this was translated into new employment opportunities for Americans, and because a new software ecosystem will be created based on Open RAN. So all very exciting. What is the issue here? That brings us to a critical cybersecurity gap. The problem is that the AI contained in the XApps will inevitably create a new threat surface for ORANs. Why? Because the AI in the XApps can be subject to adversarial AI strategies, right? So, for example, the AI can be maliciously crafted to be affected by a Trojan or a backdoor that has been infused into the model during training and then distributed through the XApps. So, in this backdoor, we have shown through preliminary results that it can be treated in real time after deployment by tampering some Open RAN interface, okay? So, in other words, freedom and openness are not free, so to speak, right? So, critically, there is no cyber infrastructure today with which we can vet AI-native XApps before deployment into the Open RAN marketplace. So, basically, operators are sitting ducks, and they need to hope for the best, that nothing has been put inside the AI and is going to ruin the RAN at runtime. So, AI complicates matters, right? Because you cannot simply apply existing software checks. The more the AI is complex and the harder it is to check, right? So, and are the key objectives of the project. So the first objective is to study algorithms to basically establish proactive and dynamic defense from these adversarial AI algorithms, and we're going to use poisoning, evasion attacks, which are very Open RAN specific, and we're also doing machine learning and other sort of algorithms to proactive and dynamic defense, okay? The second objective is to create ORAN-specific CI that will enable research groups in the US to perform AI red teaming at scale. What do I mean by red teaming? I mean that if I'm given an XApp created by a blue team, me being member of the red team, I need to check whether the AI complies with the specifications and or will perform an attack. Why do we need new cyber infrastructure for that? Well, XApps are software but it's software that interacts with the hardware, which is the run, right? So it's very, very hard to test AI in ORAN settings, right? It's not just software. So that departs completely from existing work in adversarial AI, right? So as you can see on the bottom of the slide, we will develop a new framework for Colosseum, which is a network emulator, which is any NSF-funded researcher can access free of charge to perform the AI red teaming. What is the benefit for the scientific community is that this framework will be accessible by everybody, both ORAN and adversarial ML communities. The project will be, of course, create many opportunities to educate grounded and K-12 students in this critical field of AI in Open RAN, which is of strategic importance for the US. The potential advance is, of course, establishing reproducible AI security, boosting trust in Open RAN, which we need, right, to gain momentum. And as a consequence, it will provide immense economic and social benefits for the US. That's it. That's all I have then.
Oh, that's
happy to discuss offline about this.
Yes, yeah, I think a lot of cool stuff to discuss offline. We'll follow up less so on the OSDF NDP data sharing side, but a lot of interesting intersections with some of the future G efforts and some of the other efforts at it.
Yeah, exactly.
Yep. So we'll take that offline for some follow up there. But great.
Yes, sir.
All right,
yes, sir.